Welcome to the Pinellas Home Energy Symposium. We're so glad to see you all here today. I'm Mary Campbell. I'm the Extension Director with the University of Florida. And I'm going to introduce a couple of folks in a minute that have really helped put this program together. We are so excited about the interest in home energy conservation. We have a great program for you today. I think you're going to be very excited about what you hear, as well as the opportunity to ask some questions. Let me introduce Ramona Madison Hector. Ramona is our program leader today. She's faculty with the University of Florida. And then James Stevenson. James is our extension specialist for our energy programs, and they've put this together today, and we're very happy about that. I want to welcome you to Extension. If you haven't taken Extension programs before, I want to welcome you, and I want to encourage you to come back and take other programs. We have a wide array of programs, and hopefully you'll come back and take advantage of those. We're an extension of the University of Florida here in Pinellas County, and we work to bring science-based information to our local citizens to provide solutions for your life. I want to thank our great volunteers that are here today from our Sustainable Floridian program. They're doing a great job to help us. And I also really want to thank our sponsor, Solar Source Institute. They've provided the great snacks here today, and they have their mobile training unit out front that we would encourage you to visit. The program is brought to you today through the University of Florida Extension, and it's supported by the Pinellas Energy Efficiency Project. We're very proud of the energy programs that we've developed the last few years through a federal grant. The Pinellas Energy Efficiency Project since 2009 has reached over 18,000 citizens. We've distributed 70,000 CFLs, the compact fluorescent lights. That represents over 36 million kilowatt hours saved and over $5.5 million saved. Participants from our programs report that they've had significant savings in their energy after attending our programs. We're really fortunate today to have an excellent keynote speaker. I'm going to go ahead and introduce Dr. Jennifer Languel. Dr. Languel, for more than 15 years, has championed the integration of green building principles and sustainable design within the construction industry. Today, as founder and president of Trifecta Construction Solutions, she remains an outspoken advocate and valued consultant to a wide range of industries that are incorporating sustainable building practices into their daily operations. Dr. Languel holds a bachelor's degree in materials science and engineering, a master's in civil engineering and construction management, and a PhD in civil engineering and sustainable construction. So we're very excited to have Dr. Languel. Welcome, Dr. Languel.
Well, good morning. I am hoping to indeed make this interesting because you all have gotten out bright and early in the morning. And so this should be a little sign of my kind of twisted humor. And I will thank Brittany for finding the picture of the polar bear because it was just such a classic picture we had to use it. And so this is just kind of that contrast between, it's a green Hummer. Green, and again, sometimes people think of is maybe just a color, but that has changed over the years to actually mean a movement and mean efficiency. And he was just too cute not to put up there. So that being said, as was introduced, we have, and I have over the last 15 years, so I did teach at the University of Florida. I taught in both civil engineering and building construction. And 15 years ago, this movement, again, was just really getting started. A lot of the organizations were getting started, but over those last 15 years, we have certified over 4 million square feet of green projects. We're working on many, many land developments. As much as I do have a PhD in engineering, I also am a licensed contractor. So I'm very much so boots on the ground. I like getting in the field. And you will see pictures of the kind of stuff that I do find in the field. So my background was mentioned. I did work in aircraft carrier engineering, And when I did go back to school for my master's, basically if you take an aircraft carrier and you stand it up on end, it becomes a high-rise building. So construction process is pretty consistent throughout, whether you're looking at horizontal, vertical. It is a process, and there are always room for efficiencies. And so we have worked on, as you can see up here in the top left, habitat houses, all the way to a project that we've been working on now for close to 7 years, which is the Babcock Ranch project, which is in Lee and Charlotte County. We are also working with that same developer, which is Kitson and Partners, on the Bay Pines project. So that is something that is familiar probably to most of you, that area. It is 60 acres. We are looking to do a green development certification, as well as I met with the contractors yesterday for the 330 units. And they will all be green certified as well. So this is something that we're seeing move forward aggressively. And it's not just, as you can see by the second picture down on the left, it's not just about new construction. So we're here, we know that Pinellas is one of the most built out counties in the state. And so we know you have your own homes and you're looking to improve those. As was mentioned, I was lucky enough, and maybe it wasn't mentioned, it was mentioned outside. I was lucky enough to be selected to do a series for the Discovery Channel. And it was called Project Earth. It was the follow-up to Planet Earth. And the goal of the Discovery Channel was to make you fall in love with the planet and then show you ways indeed that we could try and save the planet. And so I was both the engineer of the task force team, and the task force team is who you pictured here, which was Basil Singer, myself, and Kevin O'Leary. So if any of you watch Shark Tank, Kevin O'Leary is the middle shark on Shark Tank. And so we basically took 8 different experiments that most of academians had been working on for 30 to 40 years and scaled them up into the real world to see if they actually would go from paper and laboratory to reality. And Kevin was in charge of crunching the numbers, I was in charge of actually engineering the projects, and Basil was in charge of the science behind them. So just a couple of little pictures from that experience. When you travel filming, you don't travel light. So at times we would be upwards of 97 excess bags. And so one of my jobs was also to calculate all of the greenhouse gas emissions, because we were also offsetting all of those greenhouse gas emissions. So that being said, this was our normal packing deal. We each would get 2 of those pushing dollies, and they'd be loaded up with equipment, and that just was how it was. And this was my experience in Greenland. And so one of the experiments we did was putting down reflective sheets, and it was to see if we could keep ice from melting during the melt season. And it was more so about the fact that glaciers provide fresh water to 2/3 of the planet. And so there are places that if the glaciers do recede too much, there won't be enough fresh water supply. But you can see here by my tan, I'm not a cold weather girl. This was July on the ice sheet. We got snowed in the second time we went up there, but saw incredible things like northern lights that I had never seen. I had seen small waves before, but never quite seen things like this. This was our luxury facility. And I was pretty much the only girl up there. So every picture in retrospect looking back has a guy and his back to me, and he's in a certain stance. And I'm realizing that every picture I have is a gentleman relieving himself on the ice sheet. But that being said, I would wake up in the morning and I would find things like that. So at minus 40 degrees, the wet wipes, because there were no showers, there were no facilities up there, were a frozen solid block. And so you would have to peel off 1 or 2 sheets and then stick them inside your parka to try and defrost them to be able to use them. But, you know, that's good morning to the only woman on the site. So just very interesting stuff. We'll move into my house. I live in Alva, Florida. That is down in Southwest Florida, so it's inland of Fort Myers on the Caloosahatchee River. And so I don't know how you could drive by this house and not think it was your dream home, especially with the amount of beer that was involved apparently in this decision. But it's on the river, and we can go to the Gulf and or the Atlantic via water. And so that was a great find for us. We bought the house in 2001, so we've had it for quite some time. We call it a greenhouse because it was completely covered by vegetation at the time. It was a stereotypical 3-1. So it was built in 1974. It was you walk in, living room, dining room, kitchen, 3 bedrooms and a single bathroom with a carport. And at some point in time, someone had added on a room to the back, which was 25 by 25, which you can see here, as the house also did come with appliances. They just happened to be located in the backyard. The gentleman who lived there before us had 22 Datsuns, and so we were happy to see that there was no carpet in the house at that point, but you can also see there wasn't really a lot of drywall, and it had a vintage wagon wheel chandelier. So again, some very vintage. You can see the old jalousie windows. And we just felt like, and I felt like, there was enough building stock out there. I didn't need to build a new house. I was fine looking at this. I looked at the design and the floor plan, and I could see how to modify the floor plan to make it work for us. And so it went from a 3-1 to a 3-2, and then I kind of confiscated one of the bedrooms for a closet and relocated the kitchen. So the house works for us, and it works very well. This was my bathroom before. I originally called it where the Easter Bunny threw up. Now I realize you call it vintage because it has the avocado sinks. So again, it's a vintage bathroom, and this is the interior of it just after construction. You can see pretty stereotypical finishes. The solar tube up in the top of the ceiling, which lets natural light into the kitchen. Now keep in mind, this was done years ago, so there are many more products available now that are green that were not available when we did this renovation. Bathrooms, again, pretty traditional, just changed them over to more modern fixtures. You can see the inside of the house now with stuff in it, and I kind of show this to show you that there are lights and a big TV and a PlayStation and all of that stuff that we in society today feel like we need to have. Bedroom. And this is the front of the house. And so the new front of the house, this is all Florida-friendly vegetation. There is no installed irrigation at all. Twice a year, this is cut back and weeded. That's it. So no irrigation. When it was first installed, the gentleman said, you're going to have to walk around with a hose. And you're going to have to walk around to each plant and for 20, 30 seconds, put water on that plant. And that lasted for me 3 days. That was not a 3-month thing I had tolerance for. So this became the Darwin front yard. And if the plants wanted to be there and survive, they did. And if they didn't, they did not. And so I lost 3 plants. They didn't want to be there. I didn't want them there. We're all happy now. So I think it looks fine. The plants are larger, and we cut them back again, like I said, twice a year. But I have no issue with this front yard. And usually when I talk to developers, for example, about Florida-friendly vegetation or builders, they kind of crinkle up their nose because in their heads they have cactus and rock. And that's not what we're talking about. And you can see that in this entire campus where we are. So just to know that Florida-friendly doesn't mean weedy and rocky. Probably the most important thing is the house is 2,000 square feet. This is my July electric bill. Keep the AC set at 74 degrees. There is no solar on this house. Now, not to say that we shouldn't or couldn't have solar, but this is just showing you what we were able to do with conservation-based design. And so looking at a good building envelope, looking at good equipment, and doing that first, because those were the lower cost options. Because now if I wanted to become zero energy, I could probably do that with about 4 kilowatts of PVs. And I know one of our sponsors is a solar company, and they have a, I want to say, demonstration area outside, so I encourage you to look at that. but I also encourage you definitely to look at conservation first. And so in order to get my house up to code, I spent about $9,000. And that was, as you saw, there wasn't drywall. That back room had no insulation. It didn't have air conditioning. So I had to do some things to get that house up to code. I had possums living in the ductwork. They scared the crap out of me the first time they started moving around. And in order to get to the efficiency that I have, so I improved the insulation, I bought more efficient air conditioners, I have a programmable thermostat, I have a tankless hot water heater. That was about another $7,500 premium. What you don't see reflected in this money is what I call the eye candy. So those two numbers equal the brain candy, so to speak. The eye candy, which was the granite and the travertine and the cork flooring and the stuff that made me feel good, that was obviously an additional expense, and that by far was more expensive than the energy retrofit portion of this. The flooring and the granite alone was about that price because it was called Red Dragon and it looked really cool, and at the time that's what we wanted, so we just weren't thinking clearly. Obviously, there might have been beer involved in that decision too. And so when you look at how we score the performance of houses, just like cars have a mile per gallon, and you know with cars, the higher the mile per gallon, the more efficient the vehicle. With houses, we use a number called a HERS index. And the lower the HERS index, the more efficient the house. And so if you look at this scale, you can see that typical houses from the 70s were in that 225 and greater range. We had no building code, we had no energy code prior to 1979. So when I started taking things out of my house, there was no insulation in the walls at all. And that's just how we built in 1974. So right now, the International Energy Conservation Code sits at 100 on this scale. Florida Energy Code sits at an 85. Energy Star in the state of Florida is at a 77. My house sits at a 62. And when people talk about zero energy homes, they talk about 0 on this scale. So just to meet code right now, you need to be at an 85. So if you're thinking about the age of your house, even boom-built houses were about 20% less efficient than current code. And that's just because our energy code has changed significantly in the last few years. And so there are huge opportunities in these older houses, which I will show you demonstrations and case studies of, to improve the efficiencies. So on the scale, my house before was a 275, and it's now a 62. Yes, sir?
What is HER stand? What does HER stand for?
It's a home energy rating system. And if you look at the Florida Solar Energy Center, and there is software called Energy Gauge software, that will track you down to a place where you can find more information on that. And so again, I mentioned International Energy Conservation Code is a HERS index of 100. The Florida Energy Code is an 85, and Energy Star is a 77. Energy Star will be changing here soon. It will become a moving target. The HERS index is going to be variable depending on the size of house, etc. It's very difficult, again, and they will not do Energy Star of existing homes because you have to see behind the drywall to be able to verify that there is insulation. So that is a challenge. So when we talk about green building, I usually talk about it as both a noun and a verb. And the words are used as both a noun and a verb. These are green buildings. So these are structures that have all been certified. They are low energy performing buildings. They're healthy structures. They're water efficient structures. But green building is also the stuff we do to get houses there. And so whether we're pressure injecting foam or adding insulation or protecting our ducts during any sort of remodels or renovation, doing performance testing, adding in rain barrels, all of those actions result in a green home. And I like to think of, or I try to explain houses very much like the human body. And so in your body, you have your bones, which are your structure. You have your organs, which are, for all intents and purposes, the mechanical systems. And you have your trim, which is your skin, your finishes, what people see. Same thing in a house. You have that structure, You have the mechanical systems or the organs, which are your HVAC, your air conditioning, your hot water, all of those systems. And then you have the finishes and the trim, which is what people see. If any one of those systems is not working correctly, and whether that's in your body or in your house isn't going to perform correctly. Our biggest challenge with retrofits is that we tend to play with one of these systems without wondering or exploring how it's going to impact the other two systems. So we have older homes that really were meant to be leaky and meant to have air movement through them, and then we retrofit them and put in air conditioning and seal them up and wonder why we have poor indoor air quality. Or we add bath fans where maybe we didn't have bath fans and we're putting a room under negative pressure and finding again mold happens. And so we have to look at how these components interact with each other and not just necessarily mess with one system, so to speak. So a very, very quick example that the Department of Energy asked me to do. This was looking at conservation versus renewable energy. And so a lot of folks, because photovoltaics, renewable energy, it's cutting edge technology, are extremely interested in it. I just encourage people to conserve first. And so here's the little embarrassing fact about my house. Until I had to do this study, I didn't realize I had 61 light bulbs in my house. So 2,000 square feet. I think I'm a little obsessed with installed lighting. And I apparently like the number 3 because all of the fixtures seem to have 3 light bulbs in them. So although this was an issue, they asked and said, okay, make an assumption that each of those bulbs is running 3 hours a day. Now, I happen to be in an area where my kilowatt hour cost is 10 cents a kilowatt hour. And so if all of my bulbs, based off of that 3 hour a day assumption, were running and using incandescent bulbs, I would have about 3,600 watts total in the house. 3 hours a day, I'd have 10.98 kilowatts. If I look at that on a yearly basis, I would be using 4,000 kilowatt hours, and since it's 10 cents a kilowatt hour, it would be $400. So money associated with lighting in my house alone is $400 a year, based off of having all incandescent bulbs. If I were to change all of those bulbs to 15-watt compact fluorescents, I could drop that $400 a year to $100 a year. And if I were to change those to LED, 3-watt LED bulbs, my $400 a year in lighting could go down to $20 a year. And so looking at this, again, I have the potential for $380 a year in savings, which is about 3,800 kilowatt hours. And because to me, kilowatts and kilowatt hours are kind of out there, little numbers that don't really mean a whole lot, I converted that to gallons of gas. So that's the equivalent of 104 gallons of gas a year that I would be saving just by changing those light bulbs. If I look at the cost to do so, we did find this little retrofit 3-watt LED bulb for $6. And so compact fluorescent bulbs are running about $1. So if I changed my entire house over to compact fluorescent, it was a $61 investment. If I changed the whole house over to LEDs, it was a $366 investment. And so looking again at the payback, I put more money into the LEDs. So my first year savings is not quite as high. However, my 10-year savings absolutely is more than my compact fluorescent. Now, I'm quite honestly okay with that compact fluorescent column. It had a low initial cost. It was $61. I had a payback in my first year of $300, and over 10 years, I have almost a $3,000 payback, and that included replacing those bulbs, where with the LEDs would probably last over that 10-year period. And so if you look at generating the amount of power you would save versus saving the power. So if you look at generation versus conservation, I would need to have installed a 0.62 kilowatt system or a 620 watt PV system to generate 1,000 kilowatts, which is the equivalent of those compact fluorescent bulbs. And so based off of $6 installed, it was a $3,000 cost, and this is without rebates, without tax credits, just a $3,000 cost to generate the same amount of power I saved by putting in compact fluorescent bulbs. So it was $61 in compact fluorescent bulbs or $3,000 in PVs. I opted for $61. So I haven't gone to solar yet. And if I wanted to save the same amount as I would from going to LED bulbs, it was actually a 2.3 kilowatt system I needed. I needed to produce 3,800 kilowatt hours, which was about $11,000 installed. So again, $366 for LED light bulbs or $11,000 for PV panels. So do the conservation first, because right now this system could take my house almost to zero energy. So with all of the conservation things I've done now, this system would be all I needed to completely get off the grid. When we look at how energy is used in the state of Florida, a lot of our energy goes to transportation. We're a big state. We don't have a whole lot of mass transit options. I would say Pinellas County seems to be a lot more active in use of the multimodal transportation. I do see people actually riding your buses versus in some counties I go to, the buses are driving around empty. And we have a lot of energy that goes into residential and commercial, and a lot of that is because our commercial sector is healthcare and hospitality. So it is both giant energy sucking buildings. Hospitals and condos and or hotels are big giant energy sucking buildings. And so we have to look at how Florida indeed is using energy to say, well, where are the opportunities to save energy? And energy is not free, so to speak. These are all the major oil spills since 1960. So the Gulf oil spill, by no stretch of the imagination, was the first one that happened. And we do a lot of DoD work, and we're looking at national security when it comes to oil. So can we reduce our dependency on foreign oil is really where we're looking. And if you look at the Gulf oil spill and the equivalent of the oil that was lost, it was about 53,000 barrels per day. If you add up all of the energy lost through inefficient windows in the country right now, that is 35 times the amount of energy that was lost during the Gulf oil spill daily. Now, of course, that's national, not just Florida, because Florida windows are much less of an impact than they would be in a northern cold climate. But the reality is you don't see these windows on the news unless you were to indeed light them on fire, and then the news media might cover them. But you see the oil spill on the news. So again, it's going back to that cultural shift of what is it that we're drawn to. We can look at thermal imaging, and we can very easily take a house and put it under negative pressure and use an infrared camera and find those hot spots, find the leaks. And in the top left instance, I had someone up there, and we had walkie-talkies, and until I saw that red go away, he stayed up there shoving insulation in places. So with caulk, with weather stripping, with insulation, you can solve a lot of these infiltration problems. Again, we see mastic on ductwork here, which helps protect the tape, keep the adhesive qualities, but it doesn't mean that we don't find leaks. And so this is an easy way to look for leaks that may not be seen with the naked eye. And easy infiltration points. So most power companies will give you these little gaskets to put behind your outlets, and or there are a few cents really at Home Depot or Lowe's or any other home improvement store. And so stopping all of these points of infiltration will help you reduce your energy bill. The Florida Green Building Coalition, I'm the immediate past president of that organization, came up with some retrofit guidelines, and these are really to help consumers. What are the top 5 things I should do? Top 10 things I should do? And so they came up with a level 1 and a level 2 assessment. These assessments help you evaluate where you are and benchmark what kind of energy am I using, what kind of water am I using, because 2 retirees and a family with 3 teenagers is going to be using a completely different amount of hot water. So a change out of a hot water heater for 2 retirees may not be as much of a payback or return on investment as indeed changing out to a more efficient hot water heater for the teenagers that somehow are taking 4 showers a day. So the only time they're actually awake, they're in the shower for whatever reason. When we look at energy, some easy fixes, we can look at things like window tint, adding attic insulation, changing out light bulbs. We can provide the link to this and this assessment available online. This is just a very short capture of the different features available. I have pictures of this stuff to come, so I tend not to stay on slides with words very long. Water, same thing. Looking at, again, making sure you have a rain gauge and it's functioning. Making sure that we're looking at, can we replace some of that turf with Florida-friendly vegetation? Do we have low-flow shower heads and or low-flow toilets? The level 2 assessment starts adding in health, materials, and disaster mitigation. And so just the level 1 says energy and water. Energy and water is a payback financially for you. Health, materials, and disaster mitigation is a much broader approach to green and sustainability, looking at a more holistic, we need healthy environments, we should be selecting environmentally friendly materials, and we should be hardening buildings because we do indeed have storms and hurricanes. And so when we look at how energy is used, in this part of the state, your heating is about 3 to 4% of that piece of the pie. So heating and cooling in Florida is about 42% of where all our energy goes. In this part, it's about 3 to 4%. Now, infiltration is the heat and humidity coming in through cracks and crevices. That immediately goes into that cooling piece of the pie. So if we can seal up those cracks and crevices, it's also going to help us reduce that heating and cooling load. Appliances are also a large chunk, hot water and lighting. And there is a new piece of the pie that we've yet to add because we're still collecting data on it, but it's from all of those beautiful TVs and DVD players and PlayStations and Wiis and cell phone chargers and iPod and iPad and laptops. And so we have all of this stuff plugged in that is pulling these little phantom loads so that when we're ready to hit a remote, it will turn on. And so there's a piece of the pie that's emerging, and it's upwards of about 5%, that is all these little phantom loads and all the stuff we're charging. On a commercial building, we just did for a training squadron up in the Panhandle, they wanted to go to zero energy, and once we optimized the envelope, we optimized all the insulation and we optimized the equipment, the plug load, all the stuff they had plugged in this building was 46%. So it is that human element. We made that building as efficient as possible. We became the driving force to efficiency, the stuff we had plugged in. So why do we remodel? Well, sometimes we remodel because we don't like the decor anymore, or we inherited someone else's taste, and or things just aren't as efficient as they could be. We tend to shove stuff up in attics, and that's because we don't have basements here and we need to store stuff. And we also, over time, have added widgets, and those widgets needed wires. And so we have folks that are climbing up in the attic space, and they're compressing that insulation, as well as the Christmas decorations are compressing the insulation. And a lot of times we go up into the attics and we find personal vents. So when the cable guy was up there pulling cable and he got hot in the middle of summer, he kind of took out his little pocket knife and created a little personal vent of AC. So we find these issues up in the attics quite a bit. Most of the leaks are at the air handler. And the second place for leaks have been these personal vents, which are a very nice slit and twist. Apparently that's the motion they teach them, is a slit and twist. We also see displaced insulation. This is actually my brother's house. My brother's a pilot for Southwest, so he's also not quite right in the head. But he was complaining, he was a Navy pilot, so it's all right. He was complaining about his energy bills. And so we went up into his attic, and this is what I saw. And you can see there's some debris on the insulation. They had had some roof repairs. His house was, I believe, built in the late 80s. And I said, you know, Chris, we really need evenly distributed insulation in order to for it to work properly, we have an opportunity here because we have access to this attic space to get a radiant barrier up or to do spray foam insulation if that's something you want to do. And while we're up there having this conversation, his wife, who is psycho, comes upstairs with a vacuum. And she takes the attachments off of the vacuum and she starts with the hose vacuuming the insulation until the vacuum makes that whiny, I have no air moving through it sound. And so she is the one creating Mount Fiberglass. And so I'm like, Chris, I can't actually help you unless you keep your wife out of your attic. But that being said, it goes back to the human element of this. Things like weather stripping and caulk, very low cost to do, and again, helping us stop infiltration. Now, the challenge here is we did some weatherization work on affordable, low-income, elderly housing. And we actually found that because of the weather stripping, it was very difficult for the occupants to pull the doors shut and to lock them. And it was simply because of arthritis and or the amount of force that was needed now that it was such a tight fit. And so you really have to adjust your solutions for you and your home and what's going to work in your family situation. We also had installed air conditioning systems, Daikin air conditioning systems, which are extremely quiet. They have remote controls. And unfortunately, none of the occupants could read the remote control because the writing was so tiny on it, they had no idea what they were doing, and they couldn't hear the air conditioner running because it was so quiet. So they were so used to being blasted with cold air and being able to hear the air conditioner running that they were perpetually playing with the remote that they couldn't read. And so there was an education curve. It's just new systems are out there. We have to teach people how to use these new efficient systems, because if they don't know how to use them, you're not going to get the efficiency out of them. This is just some examples of radiant barrier. We find about a 20% bump in energy improvement going to a radiant barrier. It does keep that attic space a bit more cool, and it is a much lower cost than doing something like a spray foam insulation. This is an instance of a research study that was done, 2 identical houses, exact same orientation. One has a charcoal asphalt shingle roof and one has a white concrete tile roof. And I'm not saying use a white concrete tile roof, but when this study was done, that was the only cool roof that was available. So it was considered an Energy Star roofing, a cool roof, and what happened was the attic temperature from the charcoal roofing was 138 degrees. The attic temperature in the white concrete tile roofing was 100 degrees. So it was a 22% energy reduction just by having a cool roof. And so a lot of us out there are looking at our roofs. They need to be replaced, mine included. It was 2 years old when I bought the house. I'm trying to get every last minute out of that roof, which is also why I don't have photovoltaic panels yet. I didn't want to mount them, have to take them down to re-roof. So I'm kind of waiting again to re-roof first. But now the cool roofing and energy efficient roofing comes in all sorts of colors. And so you can do asphalt shingles. They just have mica chips in them that will help reflect the light. These all get the federal tax credits. Same thing with metal roofing. So again, you have options that are different colors out there, but the bottom line is the lighter you go, the better. So go as light as you can tolerate, and that will help you save energy. Pressure injected foams we've done as retrofits. Again, this doesn't necessarily stop thermal bridging, but it does stop infiltration. So it fills all of those cells and stops heat and humidity coming in through those cracks and crevices. You can do this as a retrofit. You do have to patch the stucco. And I will tell you, on my house, this was about $800. It was significantly less than window tint. So a lot of people think window tint is a great option. Window tint seems to be fairly expensive every time we've priced it. So here you can see some infrared images. Yes, there still is thermal bridging, but what I was looking for in that product was to stop infiltration. And again, if I have drywall up, it's very difficult to get insulation in the walls. So this was a way to get it from the outside of my house into those walls. So I did mention window tint. It is an option, but it is not necessarily that super low cost option. adding additional insulation in the attic, doing something like blown cellulose or additional batt insulation on top of whatever you have in there. Usually we'll have an R8 and R11, maybe some of the newer homes have an R19. If it was boom built, you might have an R30. We want to get that insulation up to R38. So if you have about an R11 and you add an R19 in 2,000 square feet, it's about $600. That usually will pay for itself over one summer with reduced energy bills. Looking at more efficient equipment, I put up a quick slide here just to remind people that when you're looking at efficiency of air conditioners, there are two things that you need to know about air conditioners. One is the SEER, and that's the efficiency rating. So that's the seasonal energy efficiency rating. The higher that number, the more efficient the equipment. And so Florida minimum code is a SEER 13. Energy Star minimum is a 14.5. Progress Energy gives a rebate for 15. Is that accurate, Gary? 14 and 15 Progress, and we will at the panel discuss these rebates. And the federal tax credit comes into play at a SEER 16. So if you're looking to optimize those returns, the incentives from Progress, you trip at a 14 or 15, but if you also want the federal tax credit, you need to go up to the 16. So since there are multiple places to get these incentives, you have to do your homework to figure out what are all of the incentives and rebates available to me. That cool roofing, we had a gentleman in Tampa who actually did the cool roofing. He worked for the county. It cost him $1,400 more, and between the savings that he was going to have in his energy bills and the tax credit, he figured his return was about 8 months. So yes, it did cost him more up front, but his return on investment was coming back in about 8 months. So just be aware that the different efficiency ratings are based off of SEER for most of our equipment here, and depending on the rebates you're going after, that SEER number may vary. The other piece or number you need to know with air conditioning is called the tonnage. And the tonnage is basically the size of the air conditioner unit. And so my house at 2,000 square feet has a 2-ton air conditioner. There are calculations called manual J calculations. Now, most air conditioning folks will come into your house and they will say, you have a 3-ton system, so we're going to replace it with a 3-ton system. But if you've done any of these other improvements, if you've changed your light bulbs, if you've added insulation, if you've added window tint, if you've done any of that stuff, you may not need a 3-ton system anymore. You may be able to buy a smaller system, which will save you money. But the AC guy just kind of wants to sell you the same system you had. So, and a lot of times he wants to sell you a bigger system because you may have mentioned to him, oh, it really gets hot there back in that one room. And so he's, oh, well, you need more AC tonnage. You need a bigger system. And we as Americans think bigger is better. And so it may just be indeed the leaks in your ductwork up in the attic. So we saw that infrared, we saw the thermal imaging, we saw the leaks in the ductwork. So if we fix those leaks and make sure that the air is actually getting to those rooms, again, that is a much more inexpensive solution than buying larger equipment that we don't need. Larger equipment also results in health problems. So if you have large equipment, it cycles on and off very rapidly, cools your house fast, but it doesn't run long enough to pull out moisture. So you end up feeling kind of clammy in the house. And so properly sized equipment will run for long periods of time. It will pull that moisture out of the house. If you also think about a car, you don't get the best mile per gallon unless you're running on a highway at a constant speed. Stop and go traffic, you don't get great fuel economy. It's the same with air conditioners. When that air conditioner is running, stopping and going, you never achieve the SEER rating that the equipment is possible of. So longer cycle times are much, much better for efficiency. I have a SEER 17 with a variable speed air handler. It sounds like a jet engine when it starts up. And then it cycles down to a point where I cannot hear it running. And it runs for very long periods of time. And so you literally have to put your hand up, and I only have 8-foot ceilings, so trust me, I can put my hand up and feel whether there's air blowing out or not. But again, the efficiency is only achieved if it runs for long periods of time. Energy Star appliances, of course, pretty available and pretty prevalent, but you have to definitely look for those little logos. Hot water and runtime. So this was just a funny cartoon about, I don't want to hear about you having to wait for hot water. And so there are recirc pumps available. There are point source or tankless hot water heaters that are available. We don't like the pumps that just constantly recirculate because they use a lot of energy. But they do make these pumps that have buttons you can push and or are motion activated that are, if you're okay with pushing a button to get the hot water to recirculate, then again, you can save a significant amount of water and you don't have to run gallons and gallons of water down the drain waiting for hot water. These are the energy guides that I said to look for, so you want to compare those kilowatt hours for your different appliances. The lower the kilowatt hour, the less energy it's going to use. When we look at lights, we know again, compact fluorescence versus incandescent, there's a significant amount of heat coming off of incandescents, not as much heat coming off of compact fluorescents or LEDs, which again is something that those air conditioning guys need to take into consideration when they're sizing your AC tonnage. Energy efficient lighting, it's come a long way stylistically, so don't feel that Energy Star lighting is no longer decorative, it is. And we look at performance testing, and so this is just an example of us looking for leaks in ductwork. It's very hard to capture the smoke test on camera because usually the flash on the camera gets rid of that the smoke trail. But again, you can see this is the type of performance testing that is done. We can put the house under negative pressure. We can look for infiltration and leaks to fix. Just a quick, yes, sir.
How do you do that?
So this would be a class 1 energy rater. I'm not sure, does Progress do this as a part of the energy audit? I'll refer you to Gary on that one, but in general, class 1 energy rater, which would also be found, there are a list of class 1 energy raters. Our company does this, but on the FSEC website, you can find a list of statewide energy raters that will come out and do this. Definitely do your research because there are probably less than a half a dozen I would ever use in the state. So that's just, again, my personal preference of the folks that I know do this and do this well. So they're not trying to sell you something you don't need. So a quick case study. This is a project that was a retrofit. Obviously, it needed a little facelift, I think is a good word for it. It had a SEER 8. It had R11 ceiling insulation, R1 wall insulation. It had not great windows. It had an electric hot water heater as well as incandescent bulbs. And we were able to update it to a SEER 15, R38 insulation, R8 in the walls, which is pressure injected foam. We were able to build out a small room around the air handler, which was located in the garage to get that air handler into conditioned space. We modified the windows, as well as, in this instance, added solar hot water and changed out to the compact fluorescent bulbs. And so this is what it looked like after. You can see the performance test happening in the lower shot. This is what we spent. So again, the total remodel cost was about $15,000 and change. Not an inexpensive remodel, but during the panel discussion, we actually have some information on a program that has come out that actually is a $15,000 loan that is forgiven over 5 years. So stay for the panel discussions is what that was all about. And so you can see where a lot of the money went here, and there was another $5,000 on beautification. You saw the before pictures. It needed a little updating inside, so there was some beautification cost there. The big thing is that we were able to reduce about 12,000 kilowatt hours. So you can see that we saved 8 tons of CO2 annually. And if you look at, if I was to just add photovoltaic panels to produce that energy I saved, it would have been a $40,000 system. And so again, it was a $15,000 remodel versus a $40,000 system. We were able, again, to go from an annual electric bill of $2,200 down to $936. And if these folks now wanted to go to zero energy, it would cost them much less to be able to go to zero energy. So they were about a 170 before. They're down, I believe, at a 72 HERS index now. Another example here, Stereotypical CR10, R8 insulation in the ceiling, not great windows. They were at a HERS index of 159, $1,600 a year electric bills, and able to get them for $9,000. We were able to get them down to a $918 electric bill annually. So save them $671 per year. So we go up into the attic space and we can look at the type of insulation and the depth of insulation, and we can determine what the R value is. So in this instance, it was very compressed and old bat insulation, which was only about 2 inches thick. A lot of times over time, that is all compressed. So I'm gonna have to keep moving through this. We will take questions at the end. I wanna get through this pretty quickly so I can kind of keep you guys on track. This is actually what happened in that attic space. The gentleman came and blew in brand new insulation, and I can tell you that there is no insulation that 7 inches of gives me R30. So he was nice enough to show me that he actually had not given me what I had paid for. So just keep in mind, being aware and having your own knowledge about this is extremely important. Water use. We use a lot of it. We have ways to conserve. Just keep in mind that getting water to your house also uses energy. So if you flip on that faucet and water comes out under pressure, that water has been withdrawn, purified, and pumped to your house. And then we take it back from you and we use sewage treatment plants to treat it, which also use energy. So there is an energy cost associated with water. Things like dual flush toilets, very simple. 2 buttons, you press 1 for 1, 2 for 2. It's not very complicated. Again, some of the newer designs that are using gray water. So this one, if you wash your hands, the water will go into the tank and you can use that water to flush. I'm convinced a man designed this, but here's kind of that next generation, which I'm sure IKEA will create some really nice cabinet to go around here in the not too distant future. Native drought tolerant vegetation you've seen all around. Using, again, irrigation controls are very important so that we don't waste water on irrigation as well as low flow irrigation. These are my 2 pictures of cisterns because most people think of cisterns as that farm silo and or baby death trap cistern. The reality is we do have rain barrels that don't have to be funky. They are starting to get them more stylistically designed. We're seeing, again, larger systems that are more comprehensive for homes. This is a picture of a house in Treasure Island that has an integrated cistern system. It is a zero energy home in Treasure Island. The cistern you can see is on the left. That's 2,500 gallons. It's used for irrigation water. And on the right-hand side, that is a gray water system. So she collects her laundry water, and that is used then to flush toilets. This is an old DuPont family house from 1904 that had 2 original cisterns, and we put those back into service for irrigation. So before we had county supplied water, we indeed used to collect rainwater if we needed water. So it, again, is just an option that we have. Indoor air quality. So when we look at indoor air quality, there was a sign that said, imagine breathing air worse than this, and then the tagline was, you already are. And so when we look at indoor air, we know that it's anywhere from 2 to 10 times more hazardous than outside air, and we know that people spend about 90% of their time inside. And so asthma cases have increased by more than 100% since 1976. About 1 in 9 children now have asthma, and we know that 50% of illnesses are aggravated and or in some way, shape, or form caused by indoor air pollution. And so when we look at my favorite stat, it's a baby crawling on a carpeted floor inhales the equivalent of 3 cigarettes a day. And that's from the off-gassing of the carpet, the padding, and then all of the stuff we walk on every day that we wipe off on that carpet. And so low off-gassing interior materials are very important for our health. Proper pressurization. So again, if we add mechanical systems, we have to make sure that we are balancing that out. If we modify our air filters and we go from that blue air filter that I can throw a golf ball through to a MERV 8 air filter, and the MERV is the minimum efficiency rating value. It goes up to a 16. If you go up to a MERV 8, it will help collect more of the particles in the house. If you go above a MERV 8, the problem is that you will put a pressure drop across your AC system. Your AC system will freeze up. You'll be sweating in the middle of the night and very angry at the AC system. So don't go above an 8 without getting an HVAC gentleman involved. Low VOC paints. Most major paint manufacturers have them now. VOCs are volatile organic compounds. So if you think of that new car smell, those are VOCs. And so every line and hospitals and healthcare facilities have been required now for 30 years to use no VOC paints indoors. And that's because paints will off-gas for up to 6 years. And so what do most people do when they find out they're going to have a baby? Is they go paint the nursery. And then they bring the new baby home and they put the baby in there and the baby's huffing down VOCs for the first 6 years of their life, and then we wonder why they have asthma. So again, the health component of low off-gassing materials is important. And it's not just the construction stuff, it's all of this stuff that impacts indoor air quality. So it is the candles and the perfumes and all the other stuff we bring into the house as humans. Selection of materials, durability to me is what drives most of my selection, much more so than eco-friendly, so to speak, materials. Because in our climate with termites, with flood, with hurricane, eco-friendly to me is extremely important. As beautiful as recycled glass tile is, it's $20 a square foot. So it's not in my house, it just wasn't an option, it was cost prohibitive, but it is beautiful stuff. Bamboo flooring, I'm not sure when bamboo became the poster child for green, but it did. This is from my trip to Home Depot, and I'm the absolute nerd that's sitting there taking pictures of weird things in all sorts of stores. I have no issue with China, but this bamboo flooring happens to be made in China. And my issue is that getting those materials here, this is not necessarily eco-friendly. So keep that in mind, that local materials help stimulate the local economy as well as don't have this kind of environmental impact as well. Shipping containers are something we've just started to play with. When people think of shipping container housing, they kind of think of this. This is not what we're doing stuff like this. And so shipping containers, again, this is another design that we're working on for a project in the Keys. It's a readily available material, it's completely recycled, and again, very durable in our environment. This is the last thing I'll do, which is Dr. Anna Marie with the Weather Channel's house. She purchased this property in Altoona, and it was an old farm that she wanted to rehab, and so her interior wasn't quite as bad as mine. Her house was built in '72. We do have a contest for the Ugliest Kitchen, and everyone so far has said she won the Ugliest Kitchen award. This was her before master shower. This is her house after. And so again, she had a designer come in. This is her kitchen after, which is all recycled glass and coconut and bamboo, all very lovely, beautiful stuff. I'm in actually a hidden pantry right now. This is her new master bathroom. And I always thought these little body sprayer things were kind of nuts, because I know in a restroom, if I've got the sprayer to dry my hands, the air blower to dry my hands, it's kind of annoying because you're sitting there for 10 minutes trying to get the water off of your hands. But she was thrown from a horse and actually cracked her collarbone. And so she never really appreciated this until she had lost some mobility. And so when we're looking at aging in place and building homes for life and knowing that if someone has surgery, they may not be able to move, things like that are actually very beneficial. And of course, the eco aspect would be, well, you're not washing and drying towels. That being said, just the thought of having to stand there to get blown off for 20 minutes or however long it takes. But if I couldn't move my arms to dry myself with a towel, that would be a great option. And so I'm going to bypass greenwashing. We'll stop there. I'm happy to talk about that later. This was just my funny. Just don't be sold by suggestive pictures. This is, well, at least he drives a Prius. And I do, and I will leave these slides, which just kind of summarize those energy and water saving features. as well as, by all means, if you drive out to Treasure Island and you see this house, this is the zero energy house that had the cistern and gray water system that I showed you. So it is here, it is local, and it is pretty classy. So, and I know Gary is also collecting data on that house, so you can bug him all you want for that information. So.
Very good from the University of Florida, and had a lot of really good down-to-earth information, you know. Not a lot of theoretical stuff, but a lot of practical information that anybody ought to be able to use.
There's tremendous interest in our community about home energy conservation. And so people are wanting to find out, how do I do it? Where do I start? What's the expert advice? So that's what Extension can bring to our community, is that expert advice to help them get started.
Specifically how people in existing homes can really implement low-cost, money-saving options. So as much as we all think green building and new construction, there are a lot of things we can do in our existing homes to make them more efficient.
Basically, we're going to talk a lot about our free home energy checks and preparing the envelope of the home to be extremely energy efficient. Everything from our incentives for insulation, our incentives for windows, our incentives to replace your air conditioning systems, and most importantly, duct testing and repair, which is extremely important. We will actually pay, the test is $60. We pay for $30 of that $60 to have the home tested.
There absolutely are funds out there. It's not extremely easy to track them down, but I do have a list of new incentives, which we'll discuss during the panels. But Progress Energy, for example, has great incentives. You have incentives in the form of federal tax credits as well. So there are different options out there, and we see more coming, which is great.
She was so informative. I mean, I learned so many things from her.